How do we know what we know about climate change? Join me as I travel to a remote mountain in the middle of the Pacific Ocean to find out where some of the important data in this area of science comes from. Back in 1958, a researcher named Charles Keeling started to wonder where all the carbon coming out of tailpipes and smokestacks went. He knew that if more carbon ended up staying in the atmosphere, it would cause the planet to start to warm. Keeling decided to run an experiment. He decided to watch the amount of carbon dioxide in the air over time to see if it changed. He figured he needed to do this in one of the most remote parts of the Earth. If it were rising there, he reasoned, it would be going up all over the planet. He chose the top of a mountain called Mauna Loa on the big island of Hawaii. Why Mauna Loa? Well, it's in the middle of the Pacific Ocean, so getting here is not easy. First, you have to travel to Hawaii, which is thousands of miles from the nearest land. Then you have to go up 11,000 feet, near the top of one of the biggest mountains in the world. Biggest because you have to remember the bottom of Mauna Loa is actually thousands of feet below the level of the sea. 20 miles from the nearest main highway, at the end of a tiny road, you'll find a research station run by the National Oceanic and Atmospheric Administration, or NOAA. Once you are there, the air is so pure and clean high above the Pacific Ocean. The only large city in Hawaii is on a different island, and the winds tend to go the other way. So any pollution Keeling found on the top of this mountain would mean that the atmosphere of the entire world was slowly beginning to change. In 1958, he started using this machine to measure carbon dioxide. In 1958, Keeling found there were 315 parts of carbon dioxide for every million parts of air. And Keeling found that number changed over time. In the northern spring and summer, the number went down a little, and in the fall and winter, it went back up. But year to year, he saw the amount of carbon dioxide gradually rising. Today, researchers continue to measure carbon dioxide every day. You can find it on the World Wide Web at this address. Now the Mauna Loa measurements are above 400 parts per million almost all the time. To make sure the readings are accurate, measurements are also taken in other remote locations, like the South Pole, Barrow, Alaska, and the island of American Samoa. And they show the same thing. The amount of carbon dioxide in our atmosphere is rising, and there is no other major source of this change than human activities. Besides, it just makes sense. Look at all the coal and oil and gas which we burn. Where else could all the smoke we put in the air go? The atmosphere is thinner than we often think. When I visited Mauna Loa at 11,000 feet, 1/3 of the air on the planet was below me. And we also know that more carbon dioxide in the air will cause the planet to warm. From 315 to 400 parts per million may not seem like much of a change, but remember, factories had been around for a long time before Keeling got around to taking measurements. When we first started burning oil and coal, there were only about 250 parts of carbon dioxide per million. How do we know that? Well, one way is to measure carbon dioxide in air bubbles trapped long ago in ice in Greenland or ice like this from Antarctica. It is likely that in the next few decades, we will have doubled the amount of carbon dioxide in the atmosphere. We also know that it is higher than it has ever been in the past 800,000 years. Even in small amounts, carbon dioxide is powerful stuff. It's what keeps every green plant you've ever seen alive. And it is just as powerful when it comes to climate. If we double the carbon dioxide in the atmosphere, it will cause the climate to change very strongly. And some of the most important research in this area started right here on this mountain in Hawaii. On Mauna Loa, when they speak about climate science, they say, "This is where it all began."